Alright, so I think this is recording. Let's, we're looking at Scale Packet 5, which is our exponential and logarithmic functions, and in this Scale 5F, we're solving equations of these log equations. You have to know your properties of logarithms and the definition of a logarithm and stuff in order to do these. Um, so let's take a look at this. On the left-hand side, I have a base of 2. On the right-hand side, a base of 2. But I also have a constant of 3 right there. I'm going to get the logs on one side of the equation and see if I can use my properties to condense it to a single logarithm and then convert it to exponential form. This looks like what I'm going to do. So I have the log base 2 of x minus log base 2 of 2x plus 1. And that's equal to negative 3. So now I'm not worried about the answer being negative 3. I just can't take the log of a negative value. If I have the difference of two logarithms, I have a property that says that I can write that as a single logarithm. Then I have the log of 2. X is in my numerator. 2x plus 1 is in my denominator. That's a single logarithm. That equals to negative 3. So now this is in log form. And if I convert this to exponential form, it'll be easier for me to solve. The base is 2, logarithm equals an exponent, and that's equal to this argument x over 2x plus 1. If we make this over 1, well, wait a minute, since I have a negative exponent, I'll evaluate and simplify 2 to the negative 3 as 1 over 8, because 2 to the negative 3 becomes 2 to the positive 3. If we change a negative exponent never makes your answer negative. It just changes the location of the base within this fraction. So this 2 raised to the negative third power is 1/8, and that's x over 2x plus 1. This equation is referred to as a proportion. One technique to solve proportions is to cross multiply. So if we multiply along these diagonals, what do we get? Well, the 2x plus 1 times 1, that's pretty easy. We get 2x plus 1. And 8 times x is easy also. It's 8x. So we've got that x is equal to 1/6. Now, if we plug that in, we have to make sure we don't have 0 or negative. Well, 2 times 1/6 is 1/3 plus a positive value. Hey, that's going to be positive, and 1/6 itself is positive. So I don't have an extraneous solution. This is going to be fine. All right, so let's take a look at this. I've got two logarithms. They have a base of 9. Let's collect the logarithms on one side of the equation and the constants on the other. So if I add this log base 9 of x minus 5 to each side, on the right-hand side, it'll cancel when I add that amount, and I just get 1. So on the left-hand side, I have a product rule that says if you have the sum of two logarithms of the same base, that I can write that as a single logarithm if I multiply these arguments together. So if we have x plus 3 times x minus 5, and let's shrink this up, give me a little bit of room. We've got the log base 9 of x squared minus 2x minus 15 is equal to 1. Well, I can't really go any further with my logarithmic properties, but I can either try to rewrite this 1 with a base of 9, and it's easy to do, log base 9 of 9, but for most of the time, for most students, they find it easier to convert this to an exponential form. The base is 9, a logarithm equals an exponent, and so we've got 9 is equal to this x squared minus 2x minus 15. Hey, that's a quadratic formula. That's a quadratic equation. We can use the quadratic formula, or we can hopefully factor it. So let's see. Why did I change minus 2x to minus 9x? That wasn't very smart. I have no idea why I did that. Maybe because I saw the 9, who knows. Alright, so 6 and 4 ought to do it, right? If I have x minus 6 and x plus 4. Alright, now these are possible solutions. We don't know yet if they're going to produce an extraneous answers. X6 minus 6 is 0. 6, well, 6 minus 5 is positive. 6 plus 3 is positive. That's good. We've got negative 4, but negative 4 minus 5 is negative. I can't take the log of a negative number, so x equals 6 is my only solution. So, hey, I hope that helps. I think this was the last one, and I will talk to you later. Bye.